was Fritjof Capra or the Dancing Uli Masters. And I had this very strong sensation of the possibility of joining or crossing or feeling some kind of emotive power in the contrast between the physics section and the theology section. So I felt it was really something I needed to devote myself to try to understand what was this kind of gap between what we understood as physics and what we understood as theology. And I think something I've realized in the last couple of days attending this conference was that it wasn't that I wanted to join physics into the spiritual or try to address the spiritual within physics. It was much more a feeling of the complete paradox in today's world that has been created between physics and what we call science and the material, and the spiritual and the theological. And somehow we've created a world in which these two are completely separate and have no reference to the other in the terms they use. But in this apparent paradox between these two ways of seeing the world, there's something enormously powerful. Because one of the things I want to look at in it today is the power of seeing things at their boundary. Seeing things at the boundary where one thing that's defined in one terms meets something else that's defined in completely different terms. And because we've completely isolated the scientific from the spiritual, what we've done is create such a boundary condition where there's this incredibly powerful edge or line between what we call the scientific and what we know as the spiritual. So, first of all, I'm going to follow through some of Ulrich's presentation, where he gave a historic account of how paradox had increasingly appeared and been made fundamental to physics. And finally, up until 1860 or so, physics had been always juxtaposed with the spirit and God and divinity. So Newton or Descartes or Leibniz would always talk about God as a kind of different dimension, and they would accept that what they were trying to do only had relation in terms of the spirit. But of course, when Charles Darwin was able to come up with his theory of evolution, it became possible to imagine that we didn't anymore need the dimension of the spirit, that we could come to a final understanding about what things were, and that this understanding of things in their own scientific terms could exist independently of anything else. And so it was at this point that science went on the road of trying to define itself completely separate to the God or spirit. And the very strange thing is that as soon as we tried to understand things exactly, around 1860, that what happened was that in the science, the paradoxical started to appear. So Maxwell's equations, which were created in 1861, had these two solutions, one moving forward in time and one moving backward in time, as Larissa said. And this was just the beginning, because then in relativity, the constancy of the speed of light from any perspective is once more a completely paradoxical element to the theory. There's no way we can understand that from a simply rational basis. And this went on further in quantum theory, of course, where there is absolutely no reality that can be given to any specific event. There's only this kind of statistical predictability in measurement, And Ulrich showed us yesterday some of the equations in which you could understand them by a forward and backward moving wave in time. And so, once more, the paradoxical had come completely central to what physics was doing. But of course, while this was happening in the theory, in the reality, what academia was trying to do and what the whole political situation was encouraging at that point was the idea that we were moving to a very clear and described technological utopia, and that our very aim of what we were trying to do was to remove the paradoxical and to simply grasp the exact and those elements of the theory that were specific to a very clear and exact understanding. So Orissa said yesterday about Bohr's attempt to impose on the wave equation of Schrödinger, which had this huge unpredictability in it, the idea that what it actually referred to was measurement. So he came up with a theory that what was happening in Schrödinger's wave equation, what quantum theory was actually describing, was even though it was unpredictable at its root, what it gave us was a firm and predictable statistical account of the values that would appear when we measured something. And Schrödinger and Einstein and many scientists couldn't understand where this idea had come from of measurement, which completely gave an interpretation to the equations which were not there in the equations themselves. And if you think about the idea of measurement, then what measurement is doing, and the theory, Bohr's interpretation was that nothing really exists except when it's measured, except when an observer interacts with the probabilities of what can happen and fixes on one specific value. That measurement is completely taking away from the paradoxical nature of the theory and trying to fix everything once again by saying, you're only real when I see you. You're only able to exist when you can show yourself in a measurable and quantifiable way. And those who have filled in forms trying to get funding or trying to promote their work in some way will know that annoying feeling that you're not believed except how you can be measured and quantified. So it's something that's become endemic in our very society. So the point was that even though the theory kept on coming up with more and more of these paradoxical elements, the very attempt of science as a body was to try to push away the paradoxical within the science and to fix upon things that were exact and which could still underpin this illusion that we were working towards a physics-based progress towards a technological utopia. Now, what I want to do today is talk about another movement that happened in the 60s especially, and continues to the present day. And this movement involves various mathematicians and physicists and philosophers who are trying to base physics and some of the results from modern theories on a different type of logic, which you could call a paradoxical logic. And one of the first formulators of this type of paradoxical logic was somebody called Spencer Brown, who in 1963 wrote a book called Laws of Form. And he said that instead of trying to explain away all these paradoxes that we all know about and all can recognize, such as in the work Dominique just showed, instead of trying to relate these to an exact science, an exact quantification of what's happening, Spencer Brown was saying that what we needed to do was develop a logic that allowed for true and false to exist at the same time, that allowed for a fuzzy realm to exist that didn't necessarily need to be exactly specified. And there's a great story about Spencer Brown, because after he'd written this manuscript, he wanted Bertrand Russell, the famous philosopher who was then about 90 in England, or then he must have been about 80, to endorse this theory, this mathematical theory, because Russell had written this book, Principia Mathematica, which was a kind of mathematical statement that everybody looked to. And Russell had spent a whole chapter saying that it's impossible to have paradox. And this goes back to Aristotle, saying that everything must be true or false. The law of the excluded middle, that there's no such thing as something that's both true or false. And Aristotle had this as the basis of his mathematics. But Spencer Brown's the very first page and the very first concept he introduces about his paradoxical logic is to allow true and false both to exist at the same time. So overturning the Aristotelian law of the excluded middle. And the story is that Bertrand Russell invited Spencer Brown to teach him this new mathematics. And he was in the library of this very austere place in Wales where Russell lived. And Spencer Brown says it was complete agony because Russell hadn't got a clue what Spencer Brown's mathematics was about. And it was like they were talking completely different languages. But then on the last afternoon, before Spencer Brown was due to go, Russell said to him, "Oh, why haven't you addressed functions?" And Spencer Brown said, "Well, actually, I'm not a very good mathematician." And then Bertrand Russell, who'd written Principia Mathematica, said, "Well, actually, I'm not a very good mathematician either." And so they were very much heartened by this disclosure of humility. And they spent the next hour reading the book, and Bertrand Russell completely understood then what Spencer Brown was trying to say. And the next thing that happened was that Russell said to Spencer Brown, "Oh, let's have a whiskey to celebrate, because what you've done is absolutely amazing." And having drunk the whiskey straight down, Russell, who was 85 or something, tried to get up and tottered over and knocked into the library, causing the whole pile of books to collapse on top of him. So then his wife came in saying, "What's going on here?" And I thought you were having a serious mathematical discussion. And Russell's hand appeared from behind the pile of books saying, "We've discovered something fantastic." And there's something kind of symbolic in this collapse of this library of books with exact knowledge in, and this kind of triumph of Spencer Brown's paradoxical logic. And so following on from Spencer Brown, Lou Kauffman wrote a paper called Sign and Space in 1982, in which he developed many of the ideas of Spencer Brown and showed how, starting with this very strange logic, which contains only two symbols, the coming into being of form and nothing, he shows how you can arrive at many of the theories of relativity and quantum theory. So instead of arriving at relativity and quantum theory from an exact logic of what we exactly know, he showed that many of the paradoxes of relativity and quantum theory could be naturally encompassed by this different type of logic. And Basil Hiley, who's written in our journal, Holistic Science Journal, has written a beautiful historic account of how this paradoxical logic has kind of grown into being able to be a very powerful tool in understanding what's happening in quantum theory and relativity. That actually our attempt to reference it to something that's exact and specific is actually unnecessary. We can actually get much further if we approach it from the point of view of the paradoxical as its foundation. And then we don't need to travel into a language of interpretation or explanation. So, before I go on, has anybody got any questions, or is that clear to everybody? Yeah?
If you have a logic where truth or falsehood is not clearly defined, how can you speak about this logic?
Well, the amazing thing is that you have this kind of ambiguous symbol. In Spencer's ground, there's this one ambiguous symbol and nothing. And then you have various laws how this ambiguous symbol can be applied. And if you think about truth or falsity, it doesn't have to be paradoxical. For instance, in a biological system, you can have a gene that turns itself off. So the gene is on, it turns itself off. It's off so it can come on again. It's on so it turns itself off. Now that's paradoxical behavior. But if you say that is an oscillation in time, that something is on, off, then the fact is that the fact that it's true and false isn't a knockdown paradox, because now it's something that's happening in time. So that's kind of where Spencer Brown went. That he could understand that this truth-false logic was actually saying something about how things developed in time and how they found their own coherence. So, yeah.
I heard something similar to your story, but it was with Gödel. Gödel is uncertainty. Is that related to what you said, or?
Yeah. So Gödel's. So yesterday, is it Natasha? Said to me, why do physics still believe they're on the right path after Gödel and quantum theory? Because Gödel said you can't ever have a finite description of a system, and quantum theory also denies any reality, any final conceptual reality to an individual particle. And I said it's complete madness that, having understood the limitation of its own method, that it continues to willy-nilly and regardless carry on generating theories and data and new conceptual maps. There has to be a move to something completely different, in which you're not beginning from a conceptual map, you're somehow beginning at another place.
It's you were mentioning about the paradox of simultaneously being something being true and false is what you were just mentioning. So there's this one, I think I don't know if I'm getting the pronunciation right. Are we talking about Gödel or Gödel? Is the same one? Yeah. So I remember the first theorem, one of the first theorems of Gödel was that you make a statement like the statement that I'm going to make now is false.
Yeah.
Now when you make this statement, one of two possibilities: either it is true or it is false, and both these lead you to a kind of a paradoxical situation. So how can you possibly try to fit the simultaneity of both things being happening in equal measure, where I mean one is rational and one is irrational. So how does one go about? How can you ever think of getting them?
Well, so you might think of the other examples, but I think what would be a good idea now is if I show you some examples of paradoxical thinking. So instead of trying to imagine it, we can actually see it in action. So is everybody happy with that? So one of the elements that Lou Kauffman talks about, he goes into many pages of looking at this, but it's actually something very everyday. Is the question of space. So, if we look at, he's looking at three-dimensional space, and he's looking at it through the rotations of a dice. So, if you rotate a dice through a certain angle, and then you rotate it through another angle, then where does that dice end up? That's what he's looking at, and he's trying to understand three-dimensional space through this, by trying to understand what is the structure that turns a particular phase of three-dimensional space into another aspect of it. And what he arrives at is the idea that three-dimensional space is, he finds this structure of how these rotations work, and then a quaternion structure it's called. And then he goes deeper into this and says that actually three-dimensional space is always created by reflection. Now, he then goes on to say that the reflections are something that we create in order to deepen a scene with the three dimensions that allow us to see that object as a whole entity. So the argument he uses, and we'll look at a specific example in a minute, is that imagine that three-dimensional space was something exact. It was something that had an exact meaning. So like if you had coordinates in a computer, and that every element in the world could be exactly mapped to a coordinate of one of these dimensions, then that would be a very rigid way of seeing. There would be no flexibility in it. All it would do was enable us to have a kind of three-dimensional map of the world, and all we would be able to do was reference this three-dimensional map in a fixed way. And what Kauffman is suggesting instead is that there is this kind of paradoxical structure to three-dimensional space, which is partly created by the planes of reflection we introduce in order to create these dimensions. And I'm going to give you an example of this right now. So here is a cube, which is actually on a three-dimensional cube on a two-dimensional surface. And if you look at this cube for a while, you might see that actually you can see two different cubes. You can actually feel your mind moving between one arrangement of the cube, where which is kind of in the plane of the screen, and suddenly the cube flips into another version of the cube, in which the front surface of the cube is as if it's coming out of the page of the screen and moving towards us. So can everybody see that?
Yeah.
So, and it's really amazing that when the cube flips, it's like we're completely with that new version of the cube. But if we try to say, well, that's a fixed three-dimensional object, we're deceived, because then it flips back into that other object, that other cube, which seems equally real and three-dimensional to us. But actually, it's come from the same two-dimensional diagram that presented itself in two ways. And so if we look into this more, we can actually see that it depends how we construct that axis of reflection, that plane of reflection, how we create the three-dimensional object in our mind. So actually it's us finding this quality of reflection that's going to make sense to present this object to us in a three-dimensional way. That's being applied as a kind of process in our mind that gives us this three-dimensional sense of the world. And if you think about that, that's a much more creative way of seeing that actually there's some kind of paradoxical medium between us and the world, and that we are able to make meaning from that paradoxical medium. We're able to make meaning in a kind of fluent way. So depending on what we want to put our attention, what our question is in looking at the world, we don't simply record a three-dimensional view out there, but we actively create a three-dimensional view by the planes of reflection that we're introducing into this paradoxical structure of three-dimensional space. So we've got something much more fluid when we start with paradox and understand that that is a vital part of how we see the world. So Kauffman spent a long time describing this in his book and going into the mathematics of it. But it's a very simple case of how the paradoxical has a value completely separate to the exact definitions of things in specific terms that we usually think of as classical logic. So is that clear? Right, so now I'm going to give you another example of a paradox of seeing.
Just one question.
Yeah.
Are you trying to suggest that what Kauffman is saying is that the space is also a matter is subjective?
Yeah, I'll give you another example. Just now people were looking at that object over there. Now I don't know how many of you have seen that object. I don't even know what it is. It seems completely useless. The only reason I can think of that it's here is to give us a practice in seeing three dimensions. So that object has been in our attention the whole meeting, and yet most of us won't have registered it at all. But it's only when we bring our attention to it, we begin to notice the round shape, the very peculiar thing that it is. And we start to get an understanding. So the three-dimensional map it gives us allows us to pick up some of the detail. It allows us to wonder, what is this thing? What is this whole thing? So it's very much when we bring our attention to something that the paradoxical capacity allows us then to focus on that thing. But if we don't look at it again for the rest of the meeting, it will return to flatness and insignificance. So does that answer your question?
So it is even space is in the realm of being subjective, is what you're saying.
There is a sense in which wouldn't say it's necessarily all subjective, but that the meeting of oneself as giving meaning to the world and the form that's in the world takes place through this paradoxical medium. So the objective and the subjective come into being at the same time. So let me give an... Yeah?
These are psychological issues, because in physics the cube wouldn't be in two dimensions, it would be in three dimensions, it would be coordinates from the edges.
Yeah.
That's what physics is about.
Yeah. No, so if you have...
Yeah. A paradox in physics, a paradox in perception, perhaps.
Yeah. No, so sometimes you do have something that's exactly specified in three dimensions. But we're looking at these in-between realms where there is this degree of freedom. So I'll come back to that at the end, I think. So let's go on to another paradox now, which is Einstein's theory of relativity. So again, relativity has come up a lot in this meeting, and it often seems as if what Einstein was trying to do was to create a new conceptual understanding about reality using this fixed idea of fixed velocity of light. But in a very good book called The Constancy of Light by David Grandy, he shows us that actually what Einstein's talking about is something completely everyday. And that is that light is able to bring us objects from far away without disclosing what light is. So we have awareness of an object, of a tree that's a long way away. Light gives us the sensation that that tree is here before us. And yet we don't have any access to what that light is that's bringing us that vision of that far object. So again, what David Grandy is saying, just move on to the next slide. So again, what David Grandy is saying is that the very way in which we see is mediated by this paradoxical place of light. And so what Einstein is really talking about is not light as a concept, as an academic concept. He's saying that this paradoxical realm is at the center of how we see. That we need this paradoxical realm in order to have the depth and fluidity and dimensions of our seeing, in which form, in that idea of subjective and objective, to go back to that form is neither out there in the world, we're simply recording it, nor is meaning entirely psychological and something we project on the world. But these paradoxical dimensions allow form and meaning to meet in a kind of unique and fulfilling way. And that so that the paradoxical is again an essential element of what allows our everyday seeing of the world to happen. And it's not that the paradoxical is simply hidden away in a theory and can be sort of left there as if that's the only blemish on an otherwise exact world. So I'm now, if that's okay with everybody, going to go on to the third example. The paradox of time. And this brings us back to, so this slide appeared in Ulysses' presentation quite magically. A syntropic effect.
Well, I got it to you, but in order to underline that this paradox is only in the kind order, not in the Maxwell equation.
Oh, right, yeah. Yeah, so this paradox, which brings us to the theme of this conference, is about that in all the equations of time and the Klein-Gordon equation and the energy equation, that there's these two passages of a wave moving from the past to the present, which kind of dissipates as it goes. And apparently in the mathematics there's another solution, which is a wave coming from the future, which apparently coheres into a point of unity, from which everything that future then happened was all contained in that coherent state of concentrated energy or existence that kind of fell from the future into that concentrated state of itself as a present. So the whole idea of this conference is to look at how can we work with these two notions of entropy and syntropy that are both in the mathematics, and apparently both are real things. So every time that we've talked about syntropy, everybody immediately knows what it is we're talking about. Everybody knows that syntropy is about those coherent, synchronistic moments out of time in which we seem to have a feeling of what our place is and what we need to do to act into a harmony that's somehow ahead of us. That's somehow something we're living into, rather than something that just explains us from where we've come from. And so, every time we talk about syntropy, it's like a light goes on, and a very reassuring light, because it kind of frees us from this feeling that everything is defined and this order is simply running out and we have no place in it, and we're quite anonymous in it. So what happens at those moments is that it's like we switch, like with the cube, from seeing an entropic world where everything is despairing and running down, and the order is simply losing itself into greater and greater disorder. We switch, like the cube, into another view that actually the world is entropic, that everything is moving towards order, that we're all on the verge of coming to this great coherent meaning, and that all our lives, as soon as we leave the conference room, will be completely resolved into absolute and definite clarity. So again, the problem is that we're not able to balance these two paradoxical states and to surrender to the fact that both of these are true at the same time, and that our mind wants to make one true, either the entropic or the syntropic, because that's a kind of, our mind is always trying to do that. It doesn't like the paradoxical. But to me, it's absolutely essential that we embrace this paradoxical, because that is what truly makes alive the value of the syntropic, not just as a counter-argument to the entropic, but something which allows us to find the boundary between the two, which allows us to meet something where these two independent possibilities can co-define themselves by coming together in us and giving us both a scientific world and a spiritual world at the same time. So just to begin to conclude, so there's some time for questions, that if I just move the mouse a little. So if we allow paradox, then we find this in many different places. We find this in space, we find this in time. And if we really open up to the paradoxical, then it allows for many of these paradoxical dimensions to to come together in their tensions of opposites at the same time, and this allows us to include within the paradoxical not just our view of three-dimensional space or our view of time. For instance, that time sometimes passes in a methodical way, sometimes time all seems to be present. But the more we allow these paradoxical dimensions to demonstrate the boundary where they meet in their opposition, then this allows for more things to come into that paradoxical place. So when we try to resolve paradoxes, so when, for instance, with Dominique, when she tries to explain why the conscious and the unconscious, where the paradox comes from, then we kind of take away the power from that paradoxical question about what is happening in those types of events. But if we embrace the paradoxical again and allow these opposites to find definition where they come together, then this gives power for more paradoxical dimensions to come together at this point of meeting. So also the spiritual can find a place alongside the paradoxes that we find in physics, because the more paradoxes, the more dimensions of paradox there are, the more specific it is we see our place here and now, and our kind of challenge to us as paradoxical beings, as beings with the possibility of existing in one or other state. And so just to coming up to the end, this is a picture Turner painted in 1840. And the two paintings are, one is Shade and Darkness, the Evening of the Deluge, and one is Bright and Colour, and Moses writing the book of Genesis. The morning after the deluge, Moses writing the book of Genesis. And again in these paintings you can feel that tension of opposites, that tension between the idea that we're just running down into an order that's dissipating and we have no control over, and this other amazingly light and creative and optimistic picture, which is that everything is possible. Moses is possible to give us a whole new understanding of what our responsibility is to each other, a whole new attempt to redefine who we are on this earth as beings who are open to the paradoxical. So really this is the image that I'd like to leave you with, that for me, in accepting the paradoxical, in accepting the dark, and in accepting that great tension between, which I felt at the bookshop, which I said at the beginning of the story, that it's possible to find that between science and spirit there is this actual tension. There is an actual tension of opposites beginning to meet, which is demonstrating itself as this boundary of power, which has power when we allow that paradox to be met and crossed and encountered. So I really think that that what we are doing here in trying to bring together these two aspects of the scientific and the spiritual, the entropic and the syntropic, is really to address something in the power of finding the boundary where two things that are seemingly opposite may meet and thereby define who we are. So that's where I'd like to leave the presentation, and I'll leave some time for questions.
Usually we talk of a priori statements in physics or in mathematics also as a priori statements. A-P-R-I-O-R-I, a priori. Yeah. Which means that you don't question that particular statement. It's an a priori statement.
Yeah.
So is this the fact that science of what you were saying is of the paradoxes being the way of the order of the day. Is that an a priori statement, because that implies that is what we have to take it for granted, and we don't question that?
It was to give a good example. In your presentation, you were saying about the myriad questions that come to you as a neurosurgeon when you open the brain, and this complete unfathomable reality that leads the analytical mind to question. And in your presentation you said very beautifully that the answer is in letting go of all those questions and seeing that there's a wonder behind the analytical that tries to understand the brain when you open up a skull. And so to me, the moral of this understanding of the paradoxical is to say that yes, we need the analytical, we need that understanding that takes us into the specific detail and allows us to operate on a brain. But we don't need to get carried away with this understanding, or to think that to understand it can only happen through its own terms of explanation. It's rather, as you did in your presentation, in allowing the religious and the spiritual metaphor to come in, and allowing the wonder of the universe to come in, that you really place that understanding of being a neuroscientist and a neurosurgeon. Then it finds its own place, and you can be a more empathetic and maybe a better surgeon, because you allow that knowledge to find its place in a natural way, rather than trying to use itself to define it. Yeah, somebody at the back. Yes, you.
No. I have an expression like information density, which I think is very near your paradoxes, because if you have a higher information density into something, you can't have single solutions. You have a lot of solutions in one complex in a way.
Yeah. So what's your point with that?
No, that's just a comment that this could maybe be understood in different ways.
Yeah.
The paradox could also be understood as in higher information density in an issue.
Yeah, I like the quote of Dominique where she said of Prigogine that neurons are able to surrender to a higher order, so that they create meaning to higher order. And so the idea that a complex system has so many relationships affecting each other that it's able to produce a coherent state, which is actually a meaning at a higher order. So all that work of Prigogine sort of borders on this idea of the paradoxical, that you can't fix a system in terms of its own elements. Something of how that system behaves, you can only understand by looking at it in context. So it does include that type of then. Yeah?
I've been thinking about this quote from Jung, which I can't remember in its entirety, and maybe someone else knows it, where he says, all opposites are of God, and so let us bend to their making. And to be filled by holy oppositeness, which is what I think I'm hearing you say, which for me suggests the only answer to that is humility, which is in essence what Jung said about the answer to Job. At the end, all Job can do is be humble in the face of the divine paradox, I guess you could say.
Yeah.
Does that fit with how you're seeing this?
Yeah, definitely. It's a really important thing of what I'm trying to do in my work, what I teach at Schumacher College and in the journal and in my own research, is to just open up people that there are an enormous number of possibilities, and that there is no past you that you have to live up to. You know, that there is much more a kind of dynamic engagement with these possibilities that need to be balanced, and especially at these points of crossing the boundary. Yeah, Charles?
I'm struck by the fact that both you and Dominique were talking about this from very different perspectives, and yet there's a profound similarity there. And I thought of a passage that I've always loved from T.S. Eliot's Four Quartets. Just one line that says, "But to apprehend the point of intersection of the timeless with time is an occupation for the saint. No occupation either, but something given and taken in a lifetime's depth in love, ardor, and selflessness and self-surrender."
Thank you very much.
Thank you.
Yeah. So time for one more question.
Well, I have a question.
Yeah.
Is that when we try to publish about syntropy, we have always found difficulties in the Western Christian world, whereas, for example, in the Muslim world, this paradox between entropy and syntropy is no problem, and we've been being able to publish a lot in their scientific journal. So, what would you say about that?
No, so I think there's something really profound in that in I mean, the West has gone down a path. The reason I talked about the path the West went down after Darwin, and this feeling that it could explain everything as an exact description from within its own drawer of concepts, as it were. To me, that's brought the West to a very a completely closed place where it can no longer see beyond the dimension of understanding which it feels should explain everything. So it's like it's caught in its own hand that's closed about the description of what that world is. And so in many other worlds, so when Deepak talks, or when we had that presentation at the beginning about India and what is beauty, the very underpinning of those societies is that humility and that knowledge that life and death go together, and that in understanding death we understand the amazing creativity of life, and we don't understand that in scientific terms, in terms that are purely terms of explanation coming from a theoretical dimension. We understand that miracle of life in a way that elevates us to something beyond who we are. And so, you know, I really like the name of that Muslim journal, because I'm sure that...
Well, one of the journals where we publish a lot is Neurocontology, which is, the editor is Tarlaci from Turkey, and we asked him why we're able to publish so easily in his journal, and he says, well, because in our Muslim culture, science has to be a path to arrive to God. So it's a way to arrive to God. And instead, the impression I have is that in the Christian world, science and religion have divided their fields, and syntropy in a way brings science in the field of religion, and the conflict between religion and science is not allowed.
And we do publish our own journal, Holistic Science Journal, and we'd be very happy to get contributions from anybody here, because that also attempts to take away the boundary by which we define A, subjects, B, what those subjects mean, C, what are the specializations in those subjects. And for me, that process of reduction completely loses what it is we're trying to address as human beings living at this time.
Philip, I just need the opportunity to make one last statement, which I think I must compliment you for a very beautiful and a very articulate talk on something which is very intangible and something which is very difficult to put in words. But I'll just conclude by telling you one very interesting term which is there, which we call as it's called as nirvikalpa samadhi. Nirvikalpa means supra-conceptual, and it's very interesting to understand that our entire understanding or our awareness is totally a subject of concepts. It is subject to and conditional to the concepts in whatever that we have learned from the time that we've become aware.
Yeah.
And this particular concept is that this understanding is something that is supra-conceptual. It is called nirvikalpa. Nir means that is beyond the domain of any concept. And I think that is something which we ought to probably come down to include in your talk, because when you talk of paradoxes, we are trying to understand this paradox by trying to superimpose our existing concepts, and which does not. It's like putting a square hole in a square peg in a circular hole.
Yeah.
So we have to probably abandon any concept, and then when you go to a supra-conceptual level of awareness and consciousness, is probably what we need to get to.
Okay, so I'll just answer that quickly, and that'll be the last question. Because Dominique said in her slide that no concepts are able to explain this. And really, you could understand that two ways. That either we haven't found the concepts, or no concepts explain it. But I think for the West, in contrast to the East, it's kind of necessary for us to understand where our concepts come from, to understand that they're actually relative things that help us understand the world, and that we shouldn't confuse them with the world that we name through them. And the East has always been very clear on knowing that limitation, but in the West we've become so lost in the illusion that those concepts are the world, that we've stopped looking through what the concepts are to see that actually the world is giving itself to us in many other ways than simply through the concepts. So thank you for helping me point that out. And that's the last word.